Welcome back everyone to this small RoboDK introduction. If you remember last time, I showed you how to model some simple geometries and we created together this very simple vacuum gripper that is going to be the tool for our simulation. Once you are finished creating all the geometries that you're going to need for your simulation, the next step is of course to import them and to position them in the simulated world. That is exactly what we're going to do today. So, first thing you should do when starting creating this simulated world with the geometries you've made is to create the correct reference frames, of course. It's to create the correct hierarchy of reference frames. If you see this simulation, that is our goal simulation, you can see that there are plenty of reference frames. There is one big reference frame that includes everything that is within the work cell that we are creating. Then there is a reference frame that is relative to the robot, and the robot pedestal and the robot itself are referenced with this reference frame, so that if I move this reference frame, they move together. Then there is a reference frame for this table, for this whole table. And then I also created some reference frames for the pick position, the place position, and the obstacle that we are going to avoid. Creating these reference frames is a little bit up to you, to your preferences. I honestly advise to create many of them, to use them as much as possible, because they really allows for a lot of flexibility while creating the simulation, especially if you have to do it several times to try out several layouts to see which one works better. They can really save a lot of time. So creating creating reference frames. In order to create a reference frame, it's very, very simple. If you remember, you can just click on this icon. It will automatically add a new reference frame to your simulation. If you double click on it in the simulation tree, you're going to see this very little window where you can find and you can set also the coordinates of the reference frame with respect to the other reference frames that you've created. By default, RoboDK creates the reference frames that are shifted of 1000 millimeters in the y direction. So you could see that the first one I created was 1000 millimeters from the origin of the simulation itself. The second one is at 2000 and the third one is at 3000 millimeters and so on. Of course, those coordinates do not make much sense, so we're going to go and change them. The first reference frame that we could create is, for example, the work cell reference frame, which basically needs to encompass everything that is within your simulation. It is very convenient for when you need to pick this whole station perhaps and put it into another simulation instead of just using the station reference frame. It is useful to create this one for this purpose. But for the time being, for the beginning, we are going to have them coincide. So we're going to have the work cell and the center of the station that are in the same point. But only for this case, it could not be so. Okay, so we're going to have this reference frame. Inside this reference frame, we're going to create others. So we can select this reference frame and add other reference frames. But of course, you could also create a new reference frame just inside the simulation and then drag and drop it inside the other reference frames. So you could create a real hierarchy of frames, which is what I would advise you to do, because it's very convenient, very useful structure. So we were saying inside the work cell, we're going to have a frame that is linked to the robot and later to the robot pedestal. Then we're going to have one that is linked to the table. So we're going to rename this frame as the table frame. In order to change the name, you could also, while you are still changing its coordinates, you could also edit the name from here. Okay, we are going to set the coordinates of this reference frame shortly, but not now. So we're going to create, work cell, table frame, UR3E base. Then we said we have these 3 coordinate frames for the parts that are on top of the table. Of course, since these are inside the table, when we move the table around, they're going to move, everything is going to move, everything that is inside this reference frame is going to move with it. Okay, so inside this table frame, we are going to create 3 frames, which are the pick frame, the place frame, and the obstacle frame in this case. Okay, now we have the general structure of our reference frames. They are not positioned in the space correctly just yet. We're going to do it shortly. First, perhaps we should insert our objects, insert the objects inside these reference frames. So the table, for example, the table, we are going to put it inside the table frame. We can toggle the visibility on. Here you can see the table and the table frame. So once again, if we move them, they move together. Then what do we have left to add? We have the robot pedestal that we need to add. Yeah, the robot base. I showed you last time how to model some simple geometries. This is a very, very simple geometry. It's just a cylinder. If I remember correctly, it's 800 millimeters high. But you can also find it attached to this brief introduction. So this is the robot base, and we can put it inside what is the UR3E base. You can see it here, so that our robot and our frame are one thing. They can move together. What else do we have? We have the box that we are going to move, which is, the box in this case is the obstacle that we are going to avoid. So we can drag and drop it in the obstacle frame and toggle on its visibility. And then the last object we need to position, the last 2 objects we need to position inside our simulation are the workpiece that for now we're going to put inside our pick frame, for example, and the floor for the robot simulation, which actually is for pure aesthetics purposes, doesn't really serve any specific purpose. The workpiece as well as the robot base, you could model them yourself using FreeCAD, as we did last time. The floor, actually, you can find it in the RoboDK library. At the bottom of the RoboDK library, you can find this plane. It's a 1 meter times 1 meter plane. So you can download it from here and you can add it to your simulation. Okay, so these are pretty much the objects that we're going to need. Let's position them correctly. First things first, the floor it's going to go here, at least hierarchically speaking, and the gripper should be inside our robot model. This is because the gripper is a child of the robot, which will allow us to move the tool and the robot together during our simulation. We are going to see exactly how to do it and to change the TCP, attach the stuff and so on in the next videos, but for now you can just drag and drop it inside the robot. You will see that the object gets positioned with respect to the tool flange of the robot. So for now this is fine. Okay, so before starting positioning everything, one more tip. When you open the reference frame or any object, we said that you can change position and orientation actually of the object with respect to a reference frame. First thing, you can select here the reference frame you want to use. So you can actually, usually you find here the parent of the object, but you can actually change it. So you can change the coordinate frame with respect to which you are giving the coordinates. You can use whatever you want. And second one, these are the positions and they are usually millimeters in RoboDK. The second, let's say fourth, fifth and sixth value are rotations. As you can imagine, if you click here, you can find a lot of different notations for orientations. I usually am very comfortable with the default one, which are Euler angles, but feel free to use whatever makes you feel more comfortable. So I usually go with the default one, and here if I just change these values, which are angles, I get to reorient the objects however I want in the simulation. Okay, so for positioning the objects, we are just going to have a look at how we position them in our other simulation. But I mean, you can later customize those values however they best suit your layout. Here. So the work cell frame. The work cell frame in this case, you can see it's not exactly at the origin of the pick and place simulation, but this value can really change, doesn't really affect all the rest because everything else is inside of it. So we're not going to change this value this time. We are definitely going to change where the robot base is with respect to the work cell frame, where they not to coincide with the value we already have. But I think in this case, yes, in this case, the robot base is already positioned correctly. It's just everything else that is misplaced, but we're going to correct that soon enough. Okay, so this is it. The table frame. The table frame right now is in 0900 0. In the other simulation, you can see that we had it at this position over here. So it's 800 0. We can copy these coordinates using this button over here. And then we could paste it using this one so that all the 6 values get copied and pasted in one shot. Actually, right now it's only one value, so we could very easily write it ourselves, but it's also convenient to do it this way. Okay, so the table frame is correctly positioned. Let's go have a look at these 3 frames here. So the place frame is positioned at these coordinates with respect to the table frame. This time is a lot more convenient to just copy all the values. Sorry, what did I say? Oh, it's the place frame, right? The place frame, so this is the place frame with respect to the table. These are his new coordinates, so you can see that it got over here. We can then just go have a look at this, the pick frame, and we can set our pick frame here, and you can see that it got correctly over here. Then we have the obstacle frame, the last one of our frames to position correctly. Once again, we copy these coordinates and we put them right here. Okay. Now it's starting to look much more like the other simulation. So now all the frames are positioned correctly. Now that we have all the frames positioned correctly, we can position the objects inside those frames with respect to their parents correctly, which is still a little bit of work, but not so much. We can position, for example, the floor. These are the values for the floor. We can always make sure that you're getting the coordinates and you're setting the coordinates with respect to the right reference frame, which by default is the parent. Okay, so you can copy paste all those values. Okay, looks almost finished. By the way, if you want to make your floor as yellow as this one or any color you may possibly like, and there are more options. Once you select an object, you actually can change the color however you want. There are quite a few colors you can choose and specify. Looks like the robot base. Yes, the robot pedestal and the obstacle are yet to be positioned. For the rest, it looks fairly okay. Okay, so let's go have a look at those values. The robot base with respect to our UR3E base. Okay, these are the values. And lastly, our box. Okay, we can save our work. You can see that now your simulation looks, at least visually, a lot much more this one. There are still a few things to be done, especially we need to program the robot to actually pick and place the part like this. We're going to do that over the next videos, but we're definitely getting closer.